G'day champions. Bear with me, I've got a massive dose of the flu at the moment. Yeah, that wasn't planned. Working on a Vox AC30/6 TB at the moment. And on a previous live stream last week, this was one of the amps I assessed. And it had a failed rectifier valve for reasons I'll show you shortly. And then when we replaced that, found quite a bit of buzz. I dug a bit deeper, did a bit of research, and my man Lyle, I'll share his video series on, or two video series on this and its related amplifier, the TBX, and its manufacturing issues. So this and the TBX were the first amplifiers manufactured in the Korg era of Vox, so after Korg purchased Vox from Rose Morris, and these were actually manufactured by Marshall. And you'll notice from everything, including the markings, the style of PCB, everything looks very Marshall-y from the era. So from what I gather, these were manufactured for about 10 years, from 94 till 2004, and they are the last of the UK manufactured Voxes, so they're a little bit sought after for that reason. After these models were retired in 2004, they moved all manufacturing to China. So circuit-wise, it's pretty close to the original JMI. Most of the issues with it are by the layout, how that circuit was implemented as opposed to the circuit itself. So, with my blocked nose and my headache, let's go over it. So it's a 6-input model, 5 trem, non-reverb, usual AC30 fare. Interestingly, this was their first actual valve rectified AC30 for about 20 years too. Everything since then was silicon diodes. Evidently the guys at Korg were trying to make this as close to the original AC30 as possible, but Marshall had other ideas. So before I go ripping into it, I'll just show you the buzz and how it reacts to the control changes. And looking inside, you can see the resemblance to the Marshall stuff from the era, the JCM 900s, even some of the valve state stuff. And any tech will recognise that sort of numbering system and the issue numbers from a lot of Marshall stuff. So the issue with the blown rectifier valve was caused by them taking the B+ feed essentially from pin 2 instead of pin 8. That makes all the HT current run through the actual filament because pin 8's the actual cathode. So all we've got to do is move a wire on that red one over to the one with the black lead there. But there's an inherent ground loop in this thing, and it's made by the circuit board layout. So someone's been in here and they've changed the cathode resistors and capacity. You can see it's standing up. So they've tried to do all the work from above the board, but now you've got wiggly caps. So I'm going to remove the board to cut traces and stuff anyway for the ground loop stuff, which I'll go through shortly. So we'll bed that one home or just replace it with a known quality one. Now, someone's changed the 2 cathode resistors to 150 ohm for because they're in parallel. That gives you 75 ohm total, so that'll cool the bias down a little bit. We'll see where they sit, but they haven't really gone to any effort to strain relieve those solder joints with a kink in the wire or standoffs or anything, so we'll make that a bit more sturdy. You can see some of these filter caps are standing over at a bit of an angle. Now I've had some of these Radial VX series caps in well, that Soldano thing I did recently where they were leaking, and often when a cap's leaning over on an angle like that and it's, you know, not really loose on the board, that can be an indication that the plug's starting to bulge at the bottom and maybe leaking some shmoo on the board. And you can see down here someone's replaced this screen grid resistor. That's 100 ohm. Previous one has shorted through the solder mask onto the heater trace there. Now here's a heater trace. It's like, why are you having these massive wide areas and then cutting it right down here? It's sort of like, I get, you know, you take the width, you take the girth wherever you can get it, but that's makes it a little bit of a bottleneck for the current. Not that it's a big issue with this amp anyway, because they're only EL84s, but running the heaters on the board in this manner, specifically running it under components that have high tension on them, is a recipe for disaster. And you see here previous techs fixed it up, but they haven't lifted the resistor off the board to to address what's happened over here. What's probably happened previously is this valve's gone short, so it's got a screen grid short. That's burnt that resistor, and then that heat has vaporized the solder mask, and then it's shorted to the trace as well. So it's just a recipe for disaster, this layout. So we're going to be cutting these traces and isolating them and running the heater separately in a twisted pair down against the corner of the chassis there, and tapping into where the heaters originate from, which is over here. Now in this one they've flown the heaters above the board, which is fine. That may even be okay. I'd like to see a slight more elevation to get it away from the circuitry, maybe a tighter twist. So I might replace that stuff anyway. I'd like to be able to like cable tie them together to get them, you know, closer together and more elevated, but there's not quite enough give. I've seen other specimens of this amp where they're not even, well, they're barely twisted. They might have one, they might just have one twist in them, but this is better than that, but it could be better. So while we've got the board out, reworking the screens and other stuff, cutting traces and whatnot, I'll replace the filter caps for the sake of a couple of radials. We may as well do that while we're here, and that'll give us a chance to inspect, you know, if these have been leaking, and also show you the silliness around the traces of these ones, which Lyle goes over in his video as well. I'm not going to be as detailed as him. You can go watch his videos, because at the moment I feel like I'm about to pass out. So let's get this hardware off and get this board flipped up and have a look. Alright, so straight away I've removed this knob, and someone's over tightened this set screw and cracked the plastic knob shaft, so we'll have to remove that pot and replace it. And because these pots are a weird form factor, we're just gonna have to fix one of the chassis and fly some wires to the board. Unfortunately, they're no longer available in this exact size and lead spacing, and all these pots were barely finger tight, so it's not great for the solder joints either. Makes for easy disassembly though. Now these little standoffs have a little black dome sort of nipply thing on the other side. Sometimes it's easy to remove the black thing on the other side than remove it from this side, because here you've got to lift it a good ½ inch or more to get the board to clear it. If you remove these, you don't need any clearance. It just releases it from its little catch on the chassis there. So I just use some nippers to lift that off gently, just like a little peg. Alright, so we've got some hack action to the existing sockets there. The crappy nylon things melted the body of it. I think what they've done is tried to reflow the solder joints through the hole in the chassis by jamming their iron down in there. Pretty lazy way of doing it, where you just remove a couple of pots and the jacks and the board swings up. So now we're in the same conundrum. Do we replace the lot of them? They're very low quality, but the others seem okay. If it was just that melt, you'd probably get away with it, because it hasn't affected the structural integrity of that pin. But down inside there, someone's mangled that pin up, so I'm not really trusting this socket. I might replace that with one of the Ruby style ceramic ones, and the others can stay. So an overview of this revision. The previous ground to the pot body casing, which was there, is not on this model, so there is no ground loop. There was a ground loop. You've got your ground trace runs all across here, and that's all your filter caps, and then runs across here, goes via this narrow bit, and then that's all your preamp grounds across the front there. So it's still only grounded at that one point to the star ground on the chassis. But note here, there's an unused eyelet on the star ground here, and that's got some green insulation on the wire still. So I think this was the revision where they ran the second ground but forgot to cut the trace, so there was a ground loop, and the previous techs identified that and removed it. And normally that green wire would be connected here, which is ground to the EL84 cathodes. So there's no ground loop, but they're sharing a ground via that pretty thin trace, so that's probably what's leading to the buzz. So it's more of a ground scheme rather than a ground loop thing. So we'll try cutting that trace and separating those grounds and see if that improves it. Hold on a minute. This filter cap's not stock. I just saw the installation of it and assumed it was part of the stock circuit. Then I realised the zip ties are a different colour. Usually an indication that someone else has done it after production. Then I realised it's just paralleled across the existing filter caps that are here. So, goddamn, I should have picked that up earlier, but you see a cap installed like that in the back of your head, you just think it's right, until I looked at the schematic and realised it's not supposed to be there. What doesn't make sense is this cap's dated 94, 46 week in 94. So that would have been about when this amp was first built. So was this a factory mod? So with the 33 microfarad that was in there on the first node there, that would have been like 80, pushing 80 microfarads getting thrown at the 5AR4 there, which is about 20 above what the datasheet spec is. So that was probably another thing that shortened that rectifier valve's life. So now we're at another little conundrum. Do we change that cap? Do we put them back in and disconnect that? Do we leave them both, even though that's from 1994? I mean, the LCRs do have a long life, but we're pushing it a little bit. It's 30 years, champions. But anyway, those pads still are connected to all these posts over here, so I cut those heater traces to isolate the preamp heaters from the output valve heaters, and we're going to run the wires to them because they're still running under the screen grid resistors and everything, and offer an opportunity to short out again like that one did in the past. So I've removed the components I need to clean up all the silicon. I'll reinstall what's good, or replace what I want to upgrade. We've removed all the heater wiring from the output valves. Ready to twist and shout. So here's an example. Here's the two grid stoppers for the Brilliant channel. They're connected to the jacks at this end. They're connected common up this end. You got a trace that disappears under here, re-emerges there, disappears under here, comes up here, goes under all this stuff, which is all the trem circuitry. It goes up here under the pots. You're following? Down here to the grid down here. So that's not ideal. What I'm going to do is run it on coax, mate. Cut the trace. So the Vibe trem channel's not too bad. It just comes here, goes straight up there, straight to the grid, so that can stay. But the normal channel goes across here, under this stuff, up around here, down here, and connects to the grid there. So I think I'll run coax for that one as well. So I'm just going to finish this one off and show you the result. Alright, so there's our new grid connections. Rerouted, the trace is cut at both ends, and coax telescoped at that end, and grounded to the ground plane at that end, and that's connected to the grid stoppers. So let's get all this back together and check it out. Alright, so I've got the board back in place. I think I'm going to just reconnect those choke leads because they do just make it with a bit spare. Here's the new ground up the preamp end, mounted with a 4mm nylock on the lock washer eyelet. If that doesn't get us there grounding wise, I may have to rethink to try and get the more ideal ground scheme, theoretical ideal, but it's a bit difficult with a circuit board amp because you've got to cut things, run wires, and it's a bit difficult with an AC30 in general because you've got basically 3 channels all running on a bus. So yeah, there's a certain theoretically perfect grounding way of doing it, and it's complicated just by the architecture of an AC30. So in a single channel simple amp it's a lot easier, but you've got to make some compromises in this case. But we'll see how it goes and go from there. Now, bending the board back and forth, some of those grid stoppers snapped off, so I've just prepped the leads, cleaned the eyelets, and I'm going to put some new ones on there. I'm going to put heat shrink over the resistor itself just to give it a bit more mechanical strain relief, so hopefully it doesn't bend right at the valve eyelet and snap the new leads off. Alright, there we go. Must be a boutique builder of concealable values of components. Super secret. I've left the majority of the pin there accessible in case you do want to measure the actual grid voltage for whatever reason. And spoiler alert, there are 1.5k 1 watt Yagio metal film. Alright champions, she's up and running. Sounding pretty good. Just 2 things that I not so much forgot to do, but I wanted to wait until I heard it to see what the difference is before and after. So the vibrato. So the vibrato speed on these is very fast and a very narrow range of speed adjustment. starting to sound like robot-y, sort of choppy, sort of modulated sound there. So ideally, I think that's what I want my fastest to be. What's currently the slowest, and then I want it to be able to slow right down from there. So unless you're going for like some weird Radiohead shit, I don't think that's particularly usable. So I'll do that. The vibe, you can barely detect it's there when it's full speed. It's just this weird sort of warble in the background. But on the currently slower speed, it's actually sounding nice and chewy like it should. The other thing, there's still a bit of buzz. Probably not going to be able to get rid of all of it, but what I do want to do is introduce some heater elevation riding on the cathode resistors, so we'll do that and see if that makes any difference as well. Alright champions, I'm doing a little trick here I thought I might let you in on. You know, you can send me the check in the mail, but I've got an old humdinger pot, right, that you see in the back panel of old vintage Fenders and whatever. Generally, if the circuits and transformers pretty good quality, you can get away with just 2 fusible resistors in its place. The fusible resistors will open in a graceful fashion if anything goes wrong, whereas these things like to burn, and they like to go open circuit for no apparent reason too. So I like to replace them. Now, normally I leave them in place, but I think this was on my personal amp, the 75 from years ago, and I think I replaced it with something else, like negative feedback switch or something. Anyway, long story short, I've got the wiper tied to the cathode. The thing's up and running. This is to dial out the last of the buzz, right? I played with the grounding, got it as good as I can. When you pull the volumes up, the hum doesn't increase now. So that means the ground loops are gone. Because when the ground loops were there, you might have had hum when the volumes were up, but it went away when you turned the volumes down. Typically that's a ground loop issue. The buzz was the heaters. So I've got the 2 outers connected to each heater terminal, you know, like the AC pins down on the EL84 socket here. There's just the nearest convenient point, you could do it anywhere. And the wiper's connected to my lungs. The wiper's connected to the cathode, elevated by about 12-13 volts. My god. And now we've got a variable humdinger, they call it. So it's variable resistor balance thing. Now I can't find my screwdriver to adjust it. What the hell? I had it 5 seconds ago. We get our screwdriver down there. That's all the way left. We've got buzz. That's all the way right. We've got buzz. But in the middle, we've still got buzz. So we find the null. Find the center of the null, which is about there, and there's 0 buzz. I can't hear any there at the moment. So what I'll do is now I'll measure those, take note of which terminal's which, and I'll put some resistors of that value in the circuit. So now that's locked to that value instead of having to mount this pot somewhere and deal with the unreliability of those pots. I will recreate that divider with a pair of resistors. 0 Buzztown. It'll be the quietest AC30 TBX in a Strat. Hell yeah. Oh, why do I do videos? So now just confirming what I measured with the pot. In practice, we've got 2 metal films in there. Just soldered to the last EL84. And I think the background noise is going to be louder than the amp. Extremely quiet. Extremely quiet. Happy days, champions. Time to get this thing back together and get it the hell off my bench. Alright, champions, I've scaled up those values of the heater balance resistors just to
keep their dissipation low but still maintain the same ratio. They're 1 watt metal films, they'll be happy there. And mounted them at a convenient point where there's a ground pad and the 2 windings coming from the transformer prior to those fuses. For the values, I just basically multiplied them and then by a common factor, and then found the nearest D12 values that I had in stock. Right, so regarding the Vibe trem channel, I've just got some subbed in resistors here in the oscillator just to adjust the speed, bring it down a notch, slow it down a bit, and if that's to our liking, we'll put them in place for good. And to make the rectifier's life even easier, I've put some backup diodes on there, so that will halve the amount of voltage across that rectifier because it's shared with the diodes, essentially in series with them, and if that rectifier ever does go short, they'll pick up the slack and you'll continue to be able to use the amplifier without destroying the capacitors with AC. Tonality wise, you'll still get the slight rectifier sag when you push it hard because it is still in circuit. So that's on, well, it says Vibe, but that's trem. On the slowest setting now. That's the mid setting. And that's the fast setting. Now, I was going to go slower than that, but the fast setting actually sounds good on the Vibe. So I think we'll leave it a little bit fast for the trem, because I think it really gives you the fast rotating Leslie sort of sound. Pretty nicely there. You slow it down. And it's still got a nice chewy, strong effect there even at the slower speed, but on the trem I think we're good. So let's stitch this thing back up and give it a bit of a listen, eh? Yeah, well, I'm whinging about everything. These preamp dropper resistors have about 342 volts on this pad, and it is incredibly close, like 0.5 millimeter from that ground plane. So don't do that if you're designing an amplifier. Sorry, I'm still struggling. It's been a week now. Yeah, because you could get arcing over there. Just forget about ground planes and amps. Maybe some in critical points near the input circuitry, but there's better ways to do it. She's putting out a happy 33 watts at the onset of clipping there. No oscillations or anything. A little bit of ripple on the top there, but it's an AC30. Slight amount of ghosting and ripple is normal for these. You go too far with the filtering and it doesn't sound like an AC30 anymore. The response is totally different. You can see the RMS voltage there on the readout. About 22 as it levels off. So onto the cab champions. I'm going to glue back these little flaps of Tolex here and just clean up everything, give the thing a good vacuum, get the old beetles and stuff that you find in these things out. And those cage nuts have torn up the Tolex pretty bad there, so I'll just get rid of the loose stuff so it doesn't end up finding its way into the speaker basket or something. Give everything a good vacuum, check the screws, they look a bit reamed out, but we'll just check that everything's cinched up, that the baffle's actually screwed tightly, and we're going to hard solder these connections because there's no need to have them quickly removable if you've got a jack anyway, so you can pull a chassis out. I can understand having quick connects if it's hard soldered to the circuit board inside the chassis, but there's no need here, so we'll solder them in place. We'll cut off the quick connects and actually solder it to the tabs. And I might replace this too, just for the heck of it, eh? We've gone this far. You know, it could just be the virus cells having a friggin' keg party in my lymph nodes, but sometimes when an amp sort of puts up a bit of a fight and you've got to really work to make it perform, you get a little attached to the bugger and you're kind of sad to see it go, and particularly when it sounds really good like this one. So yeah, I kind of hope to see you again in better circumstances, little legend, like at a gig rather than on my workbench again. I'll see you on the next one, legends. Hopefully I'll be less snotty, a bit more animated. Actually, making an animation would be good, eh? I just have to do a voiceover then. Maybe that's the way forward. See you on the next one, champions, if I'm still alive. Ugh.